Hello class, we're going to discuss about fractions, and like I've written, a fraction is written in the form of A, B, where A and B are numbers, and B should not be equal to 0. It should be a number greater than, it can be a number less than 0 or greater than 0, but it cannot be a number equal to 0, because any number divided by 0 is infinity, so does not give us a fraction. The upper number is called the numerator, and the one below the denominator. So basically what I mean, if you're having a fraction in the form of A over B, then it means this one is the numerator, that is the numerator, and this one becomes the denominator. So I'm saying the upper number is called the numerator, and the one below is called the denominator, like we have put it in the notes. The next point is, if the numerator is smaller than the denominator, the fraction is called a proper fraction. So if the upper number is smaller than the lower number, then such a fraction is called a proper fraction. An example is 2 over 3. You can see 2 is smaller than 3, so these are proper fraction, meaning there is no further simplification that can be taken to this fraction. Another example is 4 over 7. 4 is smaller than 7, that is a proper fraction. Next point, if the numerator is bigger or equal to the denominator, the fraction is called an improper fraction. And underline this is an improper fraction. If the upper number is bigger than the smaller one, then of course that an expression is called an improper fraction. So 5 is bigger than 3, so meaning a bigger number cannot be carried by a small number. So that one is called improper. These ones were proper because a smaller number can be carried by a bigger number. That is proper. But in this case, when you are having a bigger number carried by a smaller number, of course that is called an improper fraction. And these are the examples you can see. The numbers below are smaller compared to the numbers which are on the upper side. So those are the two cases of the fractions. And remember, an improper fraction can be simplified so that we have a whole number and a proper fraction. For instance, if you are having 5 over 3, you can write this number into proper fraction by having, remember 3 goes into 5 one times and 2 remains. So 5 can be written as 1 and 2 over 3, meaning 5 goes into 5 one times and 2 is the remainder. So 1 and 2 over 3. In this case, you can write as, this one can be written as 4 goes into this one 3 times, which is 12, and the 2 remains, 2 over 4. So meaning this one can be 3 and a half, and this one is 1 and 1 over 7. So basically, this is 3 over 4. It goes there 3 and 3 quarters. So this one can be written as 1 and 1 over 7. So I'm saying this improper fraction can be turned into proper fraction by, of course, writing an whole number in the proper fraction part on the other side. We now want to go ahead and carry out operations on fractions. If you are given a fraction part, you need to add to another fraction. What do? We need now to move to the examples on the addition. We are looking at an examples of addition, whereby we have, if you are told to add these two numbers, we are taking these two examples, whereby we are supposed to write evaluate. If you are told to evaluate these fractions, what you do, you need to turn these fractions into improper fraction. You need to turn this into improper fraction. How do you turn it into improper fraction? Just, if you look at what we did here, we say the 5 over 3 is the same as 1 and 2 over 3. Basically what you need to do, you take this 1 multiplied by this, you add to this. So 3 times 1, you get 3, plus 2, you get 5. Then you maintain this base. That is what you, if you want to get this other one, you take this base multiplied by this whole number, you get 12, plus this you get 15 over 4 the base. You take this one, 7 times 1 plus 1, you get 8 over 1. So that is what we mean by turning an proper fraction into improper fraction. This one is actually called a mixed case. A mixed case because you're having a whole number and you're having a proper fraction. Now we can look at this example. We can begin with the first one. We're having a solution there. So we will turn the first case. Remember we have said you turn this one into a proper fraction. 3 times 5 you get 15 plus 2 you will get 17. So we are saying 5 and 2 over 3 plus 1 and 4 over 5 is the same as 15. That is 17 over 3 plus 5 times 1 is 5 plus 4, which is 9 over 5. After you have simplified that, the next step will be taking the LCM. In the cases whereby you are having these two numbers where you cannot get a common number, you can multiply these two numbers. So I'm taking 3 times 5, I get 15. 3 times 5, I get 15, that is the LCM. 3 goes into 15 5 times. This is how we do it. How many times does this number go into the LCM? 5 times. So 5 times 17, you'll get 5 times 7 is 35, 85 plus. So I'm saying 5, this is 35, 85. 5 goes into this 3 times 9. 3 times 9, you get 27. If you sum up the two, you will get 85. This is 12. This is 10, 11 divided by 15. Divided by 15. So what you will get there is this one will be the same as writing 7 and 7 over 15. 7 and 7 over 15. That will be the answer. So I'm saying 15 goes into 112 7 times, and of course 7 remains, and 7 will remain. So we will move now to the next case. We'll move to the next question. We will move to part B. What we have answered is part A. We will now write, we having 3 over 3 and 3 over 5 minus 5 and a half. We are now looking at a subtraction case. This part B. Remember we have said you turn this one into a proper fraction, whereby you will have 3 times 5 times 3 you get 15 plus 3 you get 18. So it will be 18 divided by 5. The next one will be 2 times 5, you get 10. 10 plus 1, you will get 11. 11 over 2. So we have written these numbers into a proper fraction. The next thing you will do, you will take the LCM. You will take the LCM. The LCM in this case will be 10. 5 times 2, you will take 10. So 5 goes into 10 2 times. 2 times 18, you will get 36. Minus 2 goes into this 5 times. Times 11, you will get 55. Remember, this is the same as, if you subtract that, you'll get minus 9 over 10. So the answer in that case becomes minus 19. Minus 19 all over 10 is what you will get. Remember, this one will be the same as, that one will be the same as minus, because 10 will go into 19 1, then remainder 9 all over 10. So that will be the answer to this particular case. We will now be able to take a next question. We will now take a next question on multiplication. Multiplication and division. We'll take our next question on multiplication and division. multiplication and division. We want to see what happens on multiplication and division. If you are given, for instance, this, you are told 15 divided by a quarter of, and then you are given 12. Remember, the word of represents a multiplication. So if you find x or you find of, these two mean the same thing. They will be treated in the same case. If you get a multiplication, so I'm saying this one is the same as, this one is the same as writing 15 divided by a quarter times 12. It is the same case. So I'm saying where the word of is used, you can replace it with the word with a multiplication sign. Now, the most important case here is to understand there is a term that is called BODMAS. BODMAS, BODMAS is where we use, this one is brackets. This one represents brackets. This one represents off. This one represents division. This one represents multiplication. This is addition. And this is subtraction. That is subtraction. So what do we mean? Meaning, if you get a combination, fractions which are combined with various signs, you need to use this. You start with where you have a bracket, you solve the bracket part, you go to where you have off, you deal with that off, then you move to the next one which is division, you divide, then you move to multiplication, then addition, then subtraction. So whenever you are given such a scenario, do not be too fast changing the word off to multiplication before you apply the BODMAS concept. So you must apply the BODMAS concept before you turn. So in this case, we would write, it means we have a division and we have off. But off comes earlier before division. So we'll start with division with the off. So it means we will take a half, a quarter of 12. This is the same as a quarter times 12, which is equals to 3. After you solve that, we will now attach back. It means our part remains divided by the answer, which is 3. So 15 divided by 3, the answer is 5. So that becomes the answer to that particular question. So we will move ahead and look at another example. Like this. For example, you can be given a question of this kind, whereby you are told 1/6 plus a half, 1/6 plus a half, evaluate. You are told to evaluate 1/6 plus a half multiplied by 3/8, multiply 3/8 plus a third minus a quarter. If you are given such a case and you are supposed to solve, what you do, you have to write the BODMAS theme. You have to begin with BODMAS, meaning you need to get where the brackets are. After you deal with the bracket, you will go to off, division, multiplication, and addition. So that means we shall start from this point and solve that, whereby you're having a third minus a quarter is the same as remember our LCM, the LCM is 12, 3 times 4, the LCM will be 12. So if the LCM is 12, 3 goes here 4 times, 4 times 1 is 4, 4 goes here 3 times, so the answer becomes 1 over 12. That is what you get there, is 1 over 12. Then we shall move on, we shall move on and add it to this one. Remember this one is still under brackets, so that you have 3 over 8 plus 3 over 8 plus 1 over 12. This one will be the same as the LCM of 8 and 12. The LCM of 8 and 12 is 24. The LCM is 24. 8 can go here 3 times. This can go there 2 times. So this is 3 times 3, which is 9. This goes here 2 times, so plus 2. This one becomes 11 over 24. So 11 over 24 is the combined part for that. So we have solved this bracket. Remember now, our question reduces to 1 over 6 plus a half times 1 over 11 over 24. Once you are done with that, we still apply BODMAS. You cannot start from this point. We are now dictated to use multiplication. Multiplication comes earlier than addition. So we shall now take this. So a half times 11 over 24 is the same as 11 over 48. So finally you will have 1 over 6 plus 11 over 48. This one will give you, remember 6 can be able to go into 48, then our LCM is 48. 6 goes into 48 8 times, 8 times that one is, so it goes there 8 times, this is 1, so plus 11. So the answer becomes 19 over 48. 19 over 48 is the answer to this particular expression. So that is how we are supposed to handle that. We will now do one last more example. We'll do now one more last example so that we can stop there. If you are told to take these, you are given to evaluate a half into 3 over 5 plus a quarter into 7 over 3 minus 3 over 7 of we have 1.5 divided by 5. That is the question we are having, and we are supposed to evaluate. So in such a case, what we shall do, we will have to begin from. We will have to begin by using BODMAS. We shall apply BODMAS to this expression. We shall apply BODMAS to that expression and solve it systematically. So the first step is, remember, we will start with BODMAS. That is BODMAS. Remember, the first step is to open the bracket, the inner bracket. The inner bracket is 7 over 3 minus 3 over 7. Remember, the LCM becomes 21. That is 21. So 3 goes into 21, 7 times 7, 49. Minus 7 goes into 21 3 times minus 9. So this becomes 40 over 21, which is the same as which you can write as 2, not really 2, but 1 and 19 over 21. 19 over 21. So that is the first part. After you are done with that, we can now move on and rewrite it as a half into 3 over 5 plus a quarter into 40 over 21 of, remember I can simplify this and write it as 3 over 2 divided by 5. I've reduced it to that particular point. I can still evaluate. There is a bracket here. I can deal with this bracket so that I have a half into 3 over 5 plus, this is 10 over 21 of 3 over 2 divided by 5. Remember, once you are there, we can now deal with the off. Remember, after the brackets you deal with off, so we can deal with the off part, which is 10 over 21 of 3 over 2 is the same as 10 over 21 times 3 over 2. Remember, that is the same as 2 cancels here once, it goes there 5 times, 3 once, this is 7, huh? So we have 5 over 7. 5 over 7, remember now it reduces to, we have now reduced that expression into, we have 3 over 5 plus, remember now this portion is what is represented by 5 over 7 divided by 5. Divided by 5. After you reach there, remember, we will have now to use division, is the next point. So 5 over 7 divided by 5, when you are dividing, you can use multiplication, whereby you interchange, so that you have 5 over 7 times 1 over 5. If you want to change the division to a multiplication, you take the reciprocal of the number after the division. You take the reciprocal, 1 over that particular expression. So you can see now this will cancel this so that we have 1 over 7. Once you are there, remember our expression further reduces to 3 over 5 plus 1 over 7. 1 over 7. If you take an LCM in this case, you will have 35. 5 goes here 7 times, 21 plus 5. Remember, we are having a half outside there. This will be the same as a half into, this is 21, 26 all over 35. Remember, 2 cancels here, it goes there 13. So our final answer now becomes 13 over 35. Therefore the answer becomes 13 all over 35. That is what you get after doing all these evaluation. That is what you get after this evaluation, and we are now going to take a stop at that particular point.